Hey YouTube, 3D Printed Life here, and today I'm going to be bringing you a pretty special video, and quite a lengthy one at that. So I'm going to possibly timecode this, possibly not, depending how long the final cut is, but I will see. And today the discussion topic will be, no surprise, my 3-up, but mainly it's going to be highlighting each of the features about it, why I chose what I did, exactly what it does, what is the benefits and the drawbacks of each, etc. And it's just going to be about essentially everything. Because right now, other than these missing top, the extrusions that I will be putting on soon, it is done. This is what essentially the final-ish version will be. There will be modifications made, some tweaking, stuff like that, but for the main part, this stuff isn't going to change too much over the next probably few months. I'll keep updating the design, developing, maybe even longer, who knows. So I'm going to break this up into sections, and we're going to start with the frame, the main piece. These extrusions, they are 20 by 20 millimeter Misumi extrusions. I chose Misumi just because they were the cheapest for the length, and you can have them custom cut to any length you desire, essentially. So it does save a lot of time on my part, because I don't have a very easy way to cut metal, especially not metal this thick. So that was definitely good. I also tried to include as many of these metal brackets as I could, because mounting it to plastic like this, it's good, but it's not great. For the best rigidity, you need the metal. And that is why I have this upper ring. I've got 4 more brackets, oh, that flash, that have not yet gone on, that will actually go in here, and will attach those missing extrusions. I'm just waiting on those longer screws. But the reason I did it like this is because there's a plastic gap, but it's still the metal that's going to hold the frame rigid. So essentially I have a rigid square on the bottom here, and I have a rigid square on the top, so that should keep the entire frame perfectly square. This extra support will of course help, but it's mainly for mounting these corner pieces. And I also have some brackets on the verticals here and the verticals here, which should keep everything in a nice, perfect, symmetrical cube. That's the hope, at least, and from what I've seen from testing it by pushing on it, even with these top ones missing, it still holds its shape very nicely, and I know that once these top ones go in, it's going to be great, it's going to be rock solid. Alright, so moving on from the frame, which was definitely the simplest of the designs, I guess we can go to the fun one, the Z-axis. This was more of a pain to come up with the concept rather than actually design it and build it. What I ended up going with is as you can see, a dual screw and a dual rod style. I was actually inspired by somebody on YouTube who did this style, and he said it worked very well for him, so I figured why not, I might as well do the same thing, since that would allow us to keep the same 6 rods from the 2-up without having to add extra rods, because many of the ones like this, they have a rod on each side. But actually this works out almost better, because the weight of this carriage is essentially resting on the nut in here that's on the threaded rod, because that can't move, and it never will. The rest of the weight is on the linear bearing, which does have a little bit of give. So because the weight is centered in here, and it's actually a little bit to the side of this nut, the whole gantry is tipped a tiny, tiny bit, but that keeps it so it's uniform. Whereas if it were centered, and if there's a rod on each side, it could actually tip back and forth much more easily. Also, don't worry about the fact that this is very slightly tipped. First of all, I can't even see it with my own eye. But second of all, if you level this bed, the only part that's important is that the bed moves in the vertical direction. This thing could be at a 45-degree angle, but if the bed's level and this moves perfectly vertical, you will get perfect prints, no problem. The reason the 2-up did not have perfect prints is because when the gantry is slanted like this and it moves up vertically, it actually is kind of printing, like, it's printing perfectly straight up, but the bed is at an angle. So what happens is it gets messed up and things aren't actually square, they are slightly acute or obtuse depending on the angle. So this way you're going to always get square prints. There will be no issues like with the gantry sag. Now another problem that I came up with doing this dual screw system is we only got one Z stepper. So how do you do that? Well, for that one I got inspiration from Jeep Guy. He did actually 3 screw setup. He's still working on his rebuild, but it's looking pretty good. So he has 3 screws, which is of course going to be more stable. However, this is plenty stable as I've tested. And so what I did was I got a belt and I used this to drive the whole mechanism. I have the stepper motor here, which is on a bracket which I had to reinforce quite a bit with a nice big plate here to resist bending, since this is just plastic. It's got a tiny bit of give, but nothing to cause problems. That belt loops around, goes around a 36 tooth pulley with an 8mm bore for this 8mm threaded rod, and that's set on there right nice and tight. Comes around to the second threaded rod, and then goes back through. These two are for tensioning, because I accidentally got a belt that was slightly too long. Actually, I kind of got it too long on purpose, because it's better too long than too short. And so the final version will have a shorter belt, so you only need one of these tensioners instead of 2. But this also makes it so you can adjust your positioning in the bed in this direction, how far you want it back. It makes it really easy and really customizable. Now in these pieces I have a bearing in this top part, and I have a bearing in this top bottom part to support the threaded rod. If you come up top here, let me just move this down. Up top there is the same sort of thing. There's a threaded rod, bearing in there where the threaded rod comes in. And that's it for the threaded rod. For these guys we have clamps, and you're going to see these clamps all over the printer. They are essentially just blocks with screw holes in them, and then in the base we have little slots for the nuts here. And it clamps down by pressure, and that just holds it in place really tight. Same thing up top, and all that stuff is of course mirrored over here. I also have a bracket built in here just to further strengthen this this piece here, because if it's only attached at the back it will tend to wobble vertically, and you really just don't want that in general. So having this sturdy metal bracket and having a mount point here stops really any wobbling. Now coming up here, same sort of thing. I had to improvise a bit though, so that it would not interfere with the Y slider's end stop trigger. So I actually have it mounted underneath and then protruding out. So I have it mounted, the bolts aren't in right now, but it mounts at 2 points here and here and at the center. So those 3 points should, and they do, prevent any tipping motions that could possibly happen. In the Z drive here I have one of the sliding locks essentially. It's the same sort of clamping style, except inside there is a linear bearing on one side and a long hex nut on the other. And they're both in the same piece that just gets sandwiched in. And then there's holes in the top and the bottom, of course, so that the rods and threaded rod can go through. On the back of this one I have a nut. Focus, focus, focus. There we go. I have a nut and a screw which interacts with this end stop, rather this little end stop stub thing, and triggers that, so that's nice and adjustable to make things nice and easy. And that's pretty much it for the Z drive. Oh, well, also, actually, I should mention, I have these little end stop, or the bed nut holders. They're just little pieces that bolt on, and they hold the bed leveling nuts. And how this design works is essentially, if you have the bed leveling bracket pieces on the inside, you will be able to mount the original 2-up bed, as I've done here, or you can go ahead and flip them to the outside rails here. You'd only need 3 of them, and you'll be able to attach the removable acrylic bed that I will be developing soon. Now that bed is going to have a similar style to the original Ultimaker in that it will have screw holes and then bigger holes next to it, so you can sort of pop it in and it'll latch in place, and then if you slide it and you can pull it up and take it out. So it'll be quickly removable and 3-point leveling, which is from everything that I've heard, so much better than 4-point leveling. So that'll be definitely a nice addition to have once that is done. Alright, so that there is the gist of it for the Z-axis, all that stuff. The reason I did not go with a single screw axis, I should mention this because it is important. First of all, the screw that comes with the 2-up, this little guy, it's not too long. It's only about, I think, 250 millimeters long, somewhere around there. And because this gap here is 300, you really wouldn't get the most of the Z travel that you could get from the system, because you still need these rods, which are 290 millimeters, and there's no way around that. Additionally, if this was attached right to the motor, you'd need a nice coupler, and unfortunately printed couplers don't work too well. This one works pretty good. I designed it myself, but the fact of the matter is it's printed, it's not perfect, and it's not going to sit on there perfectly straight. You can always get metal flexible couplings, however they rarely make them for that size because it's a 5mm metric stepper axis to a 3/8 inch Acme screw, which is just kind of weird going metric to standard or whatever you call American measurements. And so other than that reason, also the main problem would be the weight of the basalt bed. The original 2-up basalt bed, from the people that have contacted me about it, because I asked them, said that it weighs somewhere about 2 or 3 pounds, and if you have a single Z-axis with 2 rods and 2 pounds centered in the middle here, that's going to be a lot of weight, and that can cause a bit of sag. And the problem isn't the sag if it is consistent, the problem is if the sag increases with more weight. So while you're printing, if the print is big and if it's heavy, it could actually make it sag further as it's printing, and it can cause deformations in the print. This probably wouldn't be a problem if I wasn't going to make it compatible with the basalt bed, and if I just had an acrylic bed, because that weight wouldn't really be that much. But I really did want to support the original basalt bed, being that quite a few people, probably about half the people on my wait list, as far as I know, have the basalt heated bed or are considering getting it. And so, I mean, I don't want people to waste $80 just because they want to get this and it doesn't support it. So, of course, I'm going to do my best to support it, and I have. Since this supports the original MDF bed, it also supports the basalt bed. And my phone is on the charging cable because I didn't realize how low it was. Hopefully it doesn't die in the middle of this, but I will continue anyway. So that is the gist of it for the Z-axis. What I have here, the reasons I have what's here, and the main reason I didn't do the single Z-axis. Now, for people who are looking to get this and looking to do your own single Z-axis just testing, it wouldn't really be an upgrade, to be honest. But if you're building it on your own, you want to do a single Z-axis instead of buying the parts to do the dual Z-axis, since you do have to buy the extra threaded rod, extra bearings, the extra nuts in here, and all that stuff. Of course, you're welcome to develop your own single axis version. That's why I released the source files, so that you can really do whatever you want with this. So yeah, let's move on to the top portion. First, I'll talk about the corner pieces, and then I'll go to the sliders, which are the craziest parts I've done, and then I will go to the extruder, and then just some general stuff about both. Or the 3, or whatever. Okay, these corner brackets, these are essentially the original design, which is pretty awesome. At least the frame, the main part of this is the original design. I added stuff on, but that's about it. So, what it is it's really just a frame that mounts into the corner, and each side mounts with 3 rods. The bottom, the vertical, and then the top. And then the same over here, bottom, vertical, top. And that makes it so it's as rigid as possible because it has 6 mounting points, which is pretty awesome. Although 2 of them are not connected to the rest of the frame, but it's still, it's good, it's sturdy, don't worry. So I've designed this so that it is easy to get to all the bolts for the most part, and you're able to assemble everything really without much trouble. The only one downside you could possibly see is that in order to loosen this screw here, this bolt, you have to remove this rod, because there's actually a hole, there you can see it, right in the back where this threaded rod goes, so that you can stick in the Allen key and tighten this bolt down, because there really is no way to get to it without the hole in this thing, because the rod would always just be in the way. For the rods, I went with a belt clamp style, or a bar clamp style design. I originally had set screws, but the problem with those set screws was that when you have so much force just from the screw pushing against the rod, it actually tends to just break the plastic, to split it, to crack it, all sorts of stuff that you don't want. And additionally, it wasn't too sturdy. Even if I had 2 set screws on the rod, it's only contacting the rod at 2 points and pushing it against the back side of the plastic. So really only half of the rod is supported and then 2 points on the other side. Whereas with this style, pretty much the entire rod is just encased in plastic, and it's putting pretty consistent pressure on it, which makes it extremely, extremely rigid. And additionally, these are much less likely to break, and if they do, they're really easy to print new ones and replace, whereas before with the set screws, if it's stripped out the nut hole, or if you crack the plastic, you have to reprint the whole piece. So with a lot of this design, I focused on having parts that are most likely to break being small parts that are separate, so that if they do break, it's not a big deal and you can just print out some extra little pieces. Coming over here to this, the belt thing. Actually, yeah, I should talk about these bearings real quick. Originally, I also had bearings that were sandwiching, or I had, sorry, washers sandwiching the bearing. A washer on top, a washer on the bottom, and the bearing in the middle. And that was designed to keep the belt on track. But the problem with that was, first of all, the washers were really thin, and second of all, they were flimsy. And that meant that they rattled quite a bit. And there was really no way to make them any thicker without cutting into important space that I really needed, and I couldn't take up with the washers. So what I came up with was a design that actually completely encases the bearing. It's 2 pieces like that, and it's got the guides built in. I know these already exist, but I came up with this 3D printed design, I guess you could say. And anyway, so it allows the belt to rotate on the bearing quietly and really, really easily. Plus, it doesn't have unnecessary wear on the edges, really, because it rarely ever rides up, whereas with the washers, because they were flimsy, it would ride up. So yeah, that's pretty much it. But going on to this piece still, I have, focus, there we go. This piece here is a sort of a throwback to the original design. I went back and forth a few times, but what it is now is it's a piece with a rod that goes down through the bearing, and then in the center there's a hole for the bolt, and that bolt holds everything down tight so that there's no rattling and everything stays in place, and there's a bolt back here to hold the back of this frame against it so that it doesn't move. I had to do 2 pieces here because you can't exactly print on an overhang like that and without some crazy support, and I wanted to make it so that you could print every single part here, 1, without support, and 2, on a 1-up. Yeah, a 1-up, not a 2-up, a 1-up. Every single part here is less than 4 by 4 inches base, and should be less than 5 inches tall. This one might cut it kind of close. No, actually it really won't. So yeah, you can print every single part here on a 1-up or on a 2-up. So if you do have a 1-up and you wanted to print this but you were worried because some of the parts were too big in the original design, no worries now, everything is printable on both machines. And essentially any 3D printer out there, because none are really smaller than the 1-up. So that's pretty cool, and that's definitely a great feature that I wanted to implement so that anybody can print this printer, really. And just those without a 1 or a 2-up would have to buy the rods and the linear bearings on your own, but that's really not that much of an extra cost. Maybe like an extra $50. Okay, so sorry I keep getting sidetracked. But this is all important stuff about the printer. So coming over here to the motor piece, we have the same essential design. Same thing here with the rod, same thing with the hole in the back to tighten down this piece. But this time, instead of having the bearing thing, of course, we have holes for the motor. And this is spaced so that the motor will perfectly rest up against these extrusion frames. And so what that does is that reduces the stress on, well, not really reduces the stress on the motor, reduces the stress on the plastic here, because this motor can't move at all. It just can't move. So it keeps everything nice and rigid, and again increases durability and all that stuff that you would expect. Okay, now let's go on to these Y slider pieces. These were the pieces that have given me the most trouble out of all of them, because these are the pieces that are essentially the most important in the entire printer. Without these being as perfect as they can be, the printer won't function right, it won't be quiet, and it won't be accurate. So I went through 1, 2, 3, 4, probably about 5 or 6 different big designs for this slider piece, and I finally settled on one that is really good. Still not quite perfect, but I am still working on it. So for those of you with the beta kit, if you are watching this, I'm assuming most of you who are getting the beta will be watching this because you're probably interested, but yeah, this piece is going to be one that you will probably have to reprint eventually, because I will have a redesign of it, because while it's good, I can definitely see some room for improvement. I just got to figure out exactly how to do that, because it's really given me quite a run for my money. So let's go over what I have here and what I've tried to do. So first of all, we got the bearing clamp on this back side. We have another 2-half connector piece. Half of the groove is in this piece and half is in the main frame itself. 6 nuts for securing it, rather than I used to have 4 on here, but I figured might as well make it more rigid. It couldn't hurt. And yeah, I think it is definitely a good idea to go with 6 here. And so this won't be a problem anymore. This clamp is good. I don't see any reason to change that. So coming over here, we have the end stop. Unfortunately, it's on top, but I couldn't honestly put it anywhere else for the time being. There's no room underneath. I will get to that later about why. But yeah, so I just had to stick with that. I just slide this guy over out of the way. We can see that I went with more rod clamps, of course, as I'm sure you could guess. But this time it's actually got, both of the rod clamps have one piece on each side. One is the main frame up here, and the other is a separate piece that will clamp in with 6 bolts to secure the 2 rods in place. For the bearings, this one I had to get a little bit creative. This is where I actually came up with the idea for the through hole with the bolt. So if I move down this Z tray real quick, okay, hopefully this is low enough. So if you look up here, you can see 2 little nubs sticking out and 2 little bolt heads. Focusing, there we go. So what I've actually got here is, do I have to be something? I do. I have 2 of these guys, and what they are essentially just pegs that go in, and they have holes in them for bolts. And this version, the most recent version, uses M3 by 20mm bolts, so that the entire length in here is 4 perimeters of plastic, whereas before it was just 2 because it had to be thinner to accommodate the headed bolt. But yeah, now it's even thicker, which is even better. The head of the bolt just sits right outside after this plane. It's like about 1 millimeter down into the head of this plastic piece. So that keeps everything strong, so the pegs are nice and strong. I was having issues with them breaking spontaneously before because of the thin makeup of them. But this new design is working really well so far, and it's also really quiet. Because the bolts are in here holding everything together nice and tight, it reduces the rattling, and also, once again, these pieces are more likely to break than pretty much most other parts on the printer, so having them be so small and so easily accessible was definitely a design goal I wanted to achieve, and I do believe I did so. You know what, while I'm down here, let me just show you the next part. Well, first of all, there's a hole going through here for the belts, and yada yada. These two are a little bit offset because of, well, I'm going to have to go back down anyway, but the diameter of this pulley is much smaller than the diameter of the bearings I'm using. So I had to step out one of these bearings to accommodate for that, because as many of you I'm sure are aware, if you have a belt going in a straight line and then around a pulley, you want it to be perfectly straight, because if it's not straight, if say this were out here, as this came closer, it would actually increase the tension in the belt. And you don't want a varying belt tension in a 3D printer, because that can actually cause some strange geometry, and additionally it could cause some major problems if you get to a point where it makes the tension too tight because it goes to a certain position. So definitely didn't want that. So what I did was, I could have had two pulleys here, but that would have taken up more space, so instead I just moved this pulley out a bit, and that seemed to work just fine, no problem. So both of these belts are almost perfectly parallel with the motion of the slider, which it's good enough to be quite frank with you. It is much less than a millimeter of difference, so it's nothing that you will ever see as a problem. It's the variations from that are really just due to like some wiggle in the pulleys and stuff like that, really tiny things. So that was basically as close as I could get it. So, done with this piece for now. So let's go on to this piece, this Y slider. Oh, wait, one more thing for this one. As many of you, I'm sure, are aware, HBots don't have the best reputation for going at super high speeds because they tend to cause some artifacting. So what I did to combat that was many people's designs actually had the belts loop and go along the outside of the rods, along each side. And they would be on the same plane to save space and keep things simple. But the problem with that is that when you go to move this gantry, or this slider, back and forth, it would torque it quite a bit, because the belt, the rotation, the center of rotation for the pulleys that have the belt are so far out that it causes quite a bit of torque. So what I did was I moved these guys as close as I could possibly get them together within reason. As you can see, they're about 5 or 6 millimeters apart, maybe a little more, but basically as close as I could get them to minimize any torquing that would go on when you move this gantry. And from what I've seen, it is so minimal that you won't notice it until you start hitting really high speeds. But you really should never print perimeters at super high speeds, because that just won't look too pretty. But infill and solid perimeters, or solid infill, whatever, you can go extremely fast, and with perimeters you can still go very fast and still get nice, good results. Okay, I believe that's it for this guy. Now on to this. This one I had probably the biggest change to out of the whole printer. Not really a huge change design-wise, but a huge change aesthetically, because this was actually flipped upside down. Originally, if you saw some of the earlier prototypes, this was upside down, the extruder was hanging upside down or underneath the rods, and the belt here was actually above the rods. And the reason I decided to flip it was a few things that you might have heard me mention before in the Beta 1.2 update video. First of all, it makes it more rigid because the weight of the stepper motor is on top and it's resting on this piece, so it's not, instead of swinging below, it's kind of sitting on top, and it's doesn't tend to wobble as much. There's still a bit of wobble, as you can see, but that is something I'm working on. And additionally, these pieces are cracked because I printed them in the wrong orientation, so that's most certainly not helping. But anyway, having the tip of the extruder closer to the rotation point, which is the center between these two rods, means that it reduces the amount of travel that this thing moves with the same amount of wobbling that's going on. So that results in less problems when printing at higher speeds, despite the fact that it isn't too much more rigid. But the main thing that's going to increase the rigidity of this is printing these pieces in the proper orientation, so that instead of having the printer shear lines along the length of the rod, which makes it very easy to crack, as you can see, it cracked there very slightly, more noticeably over here on both of those, but rather if I print it in this direction with the shear lines going this way, it's going to be much, much stronger, and I doubt it would crack ever, and if it did, it wouldn't really matter because it would still be holding the rods tight. So after printing that orientation, it should be a much more rigid gantry here, and you should probably be able to print perimeters at over 60 millimeters per second with no problems. Right now I'm printing at about 50, and there's only a really, really, really tiny problem with, maybe you can see it on here, with corners bumping out a tiny bit. But again, that's printing decently fast, and this is still an early prototype. So yep, so this thing was flipped upside down, but what I do have here is these corner pieces, and then I have a plate here, and the motor actually sits behind the extruder and behind this plate, and the plate separates the motor and the extruder. And from what I know, this is a completely new design that I have not seen before. I've seen quite a few designs, like on PrinterBots and MakerBots, where the extruder and the stepper motor are connected, and then the extruder bolts down to the gantry piece. But I don't think I've ever seen one that actually goes through a mounting plate and then into the extruder like this, so it's kind of sandwiched. This piece here, I should mention, is just a temporary spacer because I still haven't printed out ones, but I will get to that, I promise. So yeah, as far as I know, that's pretty much new, and it's been working really well for me. It's made it so that I could save space by mounting the motor right over the rods here, and not have the motor sticking out here, because that would just be absolutely silly. And also it's made things more rigid because, again, the weight of the stepper here and this mounting plate are both pretty rigid, and then the extruder gets mounted on there. So that's pretty good. To the bottom of this, you will see there's 6 mounting screws. Can't exactly see all of them, but they sandwich 2 linear bearings, which are hidden inside nice and secure. And on the bottom here, we have the fun stuff. This I did take a little while to think of. Camera right? There we go. That's pretty good, as long as you don't get that glare. Focus, and we're good. So what I have here is the belt tensioning system. One side here, it's got a little mechanism where it comes through a hole, loops back, and then loops on itself, and there's just a bolt to keep it from pulling through. And actually the notches on the belt hold itself together, and it makes it so that it won't slip through, so that it's a nice tight fit. But at the same time, it's really easy to do. There is no clamping, and there is no cutting the belt or drilling holes in it or anything like that. Now, the more fun part was the tensioning system, and this took me a little bit of a while to think of. It's actually this piece. There's 2 bolts here, 2 M3 by 30 millimeter bolts, which pull this little tray, and in this tray is that same little loop back thing that you saw over here, but it's on this piece. So tightening these bolts will pull the belt. The belt is wrapped around this guide to keep it in place, of course, and tightening these will pull it back and will increase the tension, and that's pretty much the gist of it. Also, you'll notice these little cutouts here and on the other side. Those are for the pulleys over here so that it can go all the way to the end, although my fan bracket is hitting because I have to redesign that, but if that weren't there, it could go all the way to the end. So, well, actually, that's kind of it. I wish my phone didn't cut me off there. A few things I should mention after this focuses. There we go. This design is, like I mentioned before, compatible with the stock bed. It's also compatible with the stock extruder. I don't have that on here, but I have a piece. Here it is. Little plate, like this guy. This essentially goes where this wood piece is. And then you got your extruder here, which will bolt on after that, just like so. And same style, the bolts would go through here, through the front, and then into the stepper. And you just have to make sure everything lines up, but that would work just fine. And there's also holes in this to allow for those screws for the hot end. So if you want to hide the heads of the screws on the back side rather than have them poking out the front, you can do that just fine. This also supports my custom extruder, and it should support, in theory, any custom extruder designed for the 1 or the 2-up, or really anything designed for the Anubis or the Ubis hot end, I believe. They're both the same measurement, so they should both work. The only thing you have to watch out for is, like I said, fan brackets, because there is limited room to the sides and even in front. So the best bet for a fan bracket would be a vertical, what's it called, like a squirrel cage blower style fan, a compression style, mounted vertically on this face, and then have the ducting come down and blow on the print head. That would be the best bet, and that will be something that I'm going to work on developing, because that will allow me to get the full X travel, whereas at the moment I'm only getting about 180 millimeters. Still not bad, but as you can see, I'm missing out on about 20 millimeters there, and, well, nobody likes to miss out on the fun. So I will be working on that. Let me just collect my thoughts for a second. Yes. One more thing, and one more important thing for those of you who care about aesthetics, because I sure as hell do. If you saw my 2-up, you would have seen that I like to keep everything nice and organized. I kept everything in cable wrap, and I tried to make the upgrades as uniform color as possible to make everything look nice. And that was one of the main reasons I did my own upgrade rather than doing Jeep Builders. Was, I know it's such a stupid reason, but I didn't like his design, how it had stuff poking out all over the place, and it didn't look too neat and organized and pretty. So, actually, one of the goals that I've been sticking to since the beginning of this build was keeping everything within the cube, and other than this poking out the top, the extruder, which I don't count too much, everything is within. Everything's within these walls. There's nothing coming out, which means, I mean, this wire is temporarily coming out, but it doesn't have to be. The benefit of this, first of all, is I just think it kind of looks neater because everything is within the cube. Nothing's poking out or sticking out the back. But the main benefit is that you can get some plywood paneling or some plexiglass, frosted or clear, and cut it to the right size and just slap it on the sides, slap it on the top half of the front, side, back, top if you have a big cutout for the extruder. You can essentially enclose the majority of this printer, which is great if you're printing ABS plastic, being that you don't want any drafts at all when you're printing it. And it's good too for PLA, just to have a sort of controlled environment. And it's good for aesthetics because it makes it look so much nicer to have an enclosure. And I would love to do an enclosure, but it's somewhat expensive to do, so I'm going to hold off on that for a while. But I did create some DXF files, which are standard laser cutter files, so that you can, if you have access to a big laser cutter, or you know somebody who would do it for you, or something like that, you can just cut out your panels and then bolt them on however you choose. Best bet for doing that would probably be to get 4-slot corners so that you can just bolt along each of these corners. And yeah, that would be that. For the other part of the aesthetics, I'm looking to mount the printer board and the power supply. I'm looking to do the power supply laying flat along this top bar, coming in over here. It would go over the belt and whatever. It'd probably have some kind of plastic bracket going over the belt to make sure it didn't rub or anything. And the printer board I'm looking at mounting along one of these verticals so that the cable and the SD card are both facing out of the side. And then I'm also looking to do, let me see, where's the, there we go, a nice power button, because I am so sick and tired of unplugging that little plug right there. Every single time I want to turn it on and off, a power switch would just make life so much easier. I'm not even kidding, especially because that's a really tight socket and it's just a pain. But yeah, so I'm looking at doing a mount for the power switch, probably somewhere. I don't really know yet. Possibly along the printer board, possibly somewhere on the power supply bracket, but I'm definitely going to look at mounting a power supply, and that's going to be something that I can't exactly sell with the kit, because you would have to solder the wires on here yourself, so I mean it's kind of pointless to include it. I might include the power switch, I guess, but I'll see about that stuff later. But anyway, power switch is definitely to come, at least the design for it, so that you guys can do it yourself, and the printer board and all the mounting stuff to make it pretty. That's last priority. Along with that, I also found some nice printable cable chain for these wires, because this gantry moves quite a significant distance. The maximum distance here from the center, which is where I would mount the start of the cable, to here is about a little under 300 millimeters. Actually, it's to the back here, because that is where it would be. It's 300, and then it goes down to a pretty small amount, so I'll have to figure that out, exactly how I'm going to do that. I would like to do some kind of cable chain management thing, but I do know that those things can tend to get a little haywire, especially when you get closer to where the two ends are mounted, because then it's got a big tail sticking out somewhere and it's hard to control. So I'll look into that. I'll experiment with some different things once I get some more time and once I have more plastic to work with. You can see the bare spool. I still have a tiny bit, but it's not enough to really do anything, so I will probably print that later tomorrow. But that is all that I can think of right now. That's pretty much the entire design. End stops, of course, full end stop support. I didn't mention it, but there's a Y end stop. And there is a piece here that is purposely broken off because I printed this slightly wrong version. So the little drop down where that would contact the Y end stop isn't there. But the X end stops here, the Z end stop, like I've mentioned before, is here, and the Y is here too in all the design files, and I just got to reprint it. And full support for stock stuff, and it reuses them as much as possible. In total, this reuses, not including electronics, extruder, and stepper motors, it reuses all six of the 290mm 8M8 steel rods from the 2-up. If you have the 1-up, you'll have to buy 4 more of them because you only have 2 of those long rods. It reuses 6 of the linear bearings, which is all of the 1-ups, and it is 1 less than the 7-up, or not 7-up, 1 less than the 7 that you get with the 2-up, which is good because if you have one that isn't quite as good as the rest, you can just toss that one out, or save it just in case, but you don't have to use it, which is good. It also reuses 2 of the 3 large bearings. Those guys go on here, these 2 end pieces, and it also reuses... I know there's one more thing. Oh yeah, it reuses the bed leveling, the bolt, the spring, and the nut. Reuses that whole set. It also reuses some various hardware, M8 bolts. These guys going to the motors, these are M8, 3x8mm bolts, I'm losing my mind, that are used to mount those. It reuses 10 of those from the original design, so you do have to get 2 more. But being that you're ordering parts from Asumi already, it's not that hard to just throw in 2 bolts for like 10 cents each. And I believe that is everything that it reuses. Like I said before, I would have liked to reuse the original threaded rod, because adding 2 new threaded rods does cost about $10 or $15. Not to mention all the other parts that have to go along with it. But in the end, the dual rod system is going to be much more stable and just much better in general. Plus, it doesn't look super pretty, but using the big awkward bed, if you had to use that with a single axis, that would just kind of look weird and it would stick out really far. So perhaps it does look a little better. And again, if there were panels to cover up the sides, I just think it would look amazing. I did some renderings to see, but they really don't show realistically what it would look like. That shows like that's the case scenario. So maybe one day I'll get those panels on the side here and see exactly what it looks like with all them, and I think I would be extremely impressed, but until then I'll just have to wait. So that's pretty much it for this extremely long video. I do apologize. If you did stick around to the end, thank you so much for watching. I hope you enjoyed it, and I hope you learned quite a bit about this design, and hopefully I have convinced you, if you were thinking about it, to build one of your own. I should mention some quick specs. Probably should have mentioned these at the beginning, but what can you do? Build travel is 193mm, 203mm, 200 give or take. That depends on the thickness of your bed and a few other factors, but it varies between 180 and 200. It can print down to, I've tried down to 0.1mm, and I know without a doubt it can probably go lower, because it does have a nice accurate threaded rod, even more accurate than the Acme screw on the 2-up and the 1-up. So 50 micron print should be no problem for this thing. I just haven't gotten around to try them because they take a long time to do, and I've been prototyping my butt off with all this stuff. So and specs. Oh yeah, price. To build this yourself, it ends up costing about $250. And you do have to print somewhere between 30 and 50 hours to print all of the parts. This depends on the speed of your printer. This printer can do them all in 30 hours, but if I did them on my 2-up, it would have taken it closer to 40 or 50, which isn't super bad, but it is a long time, and especially when you have to kind of print just a few parts at once to make sure you can test them and they come out right. As far as filament usage, it will use about half a spool of your 1 kilogram spools. It's about 400 cubic centimeters, which is about half a kilo. And I think that's about it. I'm going to go to sleep now. So this is a pretty long video, and yeah, so I'll leave you all alone. Hope you enjoyed. Links are all down below if you're interested. If you enjoyed, please like and subscribe. Thank you for watching. I'll catch you all later.